We want to start by implementing a pan gesture recognizer, which will enable us to move our scene around so that we can see all of it. I will define my recognizer right below the camera as a new property, and it will be a variable called pan recognizer. And I will initialize it as a new UI pan gesture recognizer instance without any parameters. Right below didMoveToView, I will now create a new method, which I will call setup gesture recognizers without any parameters. And I will call this method right after calling addCamera from my didMoveToView method. Inside of my new method, I want to initialize my gesture recognizers and assign the appropriate target and action, which will define what should be executed if my gesture recognizer is triggered. Since we do need to add a gesture recognizer to a view, I will start the method by, once more, checking if we have a valid view with a guard statement. So let's write guard let view is view, and in the else part, I'll just return to abort the method. If I do have a valid view here, I can add my gesture recognizer to it by writing view.addGestureRecognizer and then passing my pan recognizer as the one I want to add. I then have to specify a target and an action for my pan recognizer. And to do so, I will at the very bottom of my file, below the class GameScene, add an extension. Let's write extension GameScene, and inside of these curly brackets, I want to add all functionality that has to do with our gesture recognizer. Some of you may know that methods I intend to use as actions with selectors need to be prefixed with the addObjective-C attribute. So let's do this. Other than that, it will just be an ordinary method called pan, which will get a parameter sender of type UI pan gesture recognizer. And I now want to call this method each time our pan gesture recognizer is triggered. To do so, I will initialize it as a UI pan gesture recognizer with a target and an action parameter. For the target, I will say self, so the game scene itself, and for the action, I'll write selector and then pass my new method pan to it. Now each time our pan recognizer registers a pan on the screen, our pan method will be called. So let's scroll back down and implement it together. The code itself won't be that complicated, and I'll start by creating a constant called translation, which I will set to sender.translation in view, and I can see in the description of this method that this just translates our pan gesture to the coordinate system of the past view. And I will, of course, pass the SK view of our scene. I will once more have to make this value non-optional with our usual guard statement, which should save the view in a constant. And else, we return. While we could technically just use an exclamation mark for the view, it is a little safer to just unwrap the value using a guard statement. As soon as we have this translation, which specifies the positions inside of our view, I want to update the position of my game camera. So I write GameCamera.position, and I want to set it to a new CG point, which I will define going off of my current camera position, and simply adding the translation of my pan gesture. So for the X value, I'll start with GameCamera.position.x, and I now want to subtract translation.x. For the Y value, I will start with GameCamera.position.y, but this time I want to add the translation value. So I'll write plus translation.y. Now why do I subtract the X value and add the Y value. By doing it this way, we just simulate a normal dragging or scrolling behavior that the user would expect, since on the x-axis, smaller values are to the left and bigger values to the right. On the y-axis, bigger values are to the top and smaller values towards the bottom. So by subtracting x values and adding y values, we get the same behavior we would get in a scroll view, for example. All that's left to do is, at the end of my method, reset the translation of my sender, so that the next time the method gets called, we offset the camera by the right values. I can do so by writing sender.setTranslation, and I will set it to cgPoint.0 in my view. And that should be it. So if you run the app now, which I will do, we should be able to pan around in our scene and by moving the camera see all of our map. The app started, and if I now click and drag, we can see that it seems to be working. However, on the simulator it is moving really slowly and the frame rate is pretty low, so maybe we should try to run this on an actual device where we might be able to test this feature better. So let's just do that. Alright, on the device this is looking much smoother and we can now see that I can drag around in my scene. The problem is, however, that I can now pan too far so that we can see the black background of our scene, which we obviously don't want. We should probably fix this so that a user of our app cannot pan so far that he or she sees beyond our tile map. To be able to achieve this, we will create a custom camera class so that we are not just using a regular SK camera node here, but instead a custom subclass that will have the functionality built in to respect the borders of our scene. I will create a new group in my project, which I will call custom nodes. And inside of this group, I will create a new file as a Cocoa touch class, which will be a subclass of SK camera node. I will call my new class game camera and create it. As always, I will have to replace the import at the top so that the SpriteKit framework is imported and we don't get any errors. We can then start implementing our game camera class together. Inside of our game scene file, I will of course change the initialization of our camera to be a game camera and not a SK camera node. To actually change the behavior of my camera though, I will of course have to work on my game camera class, where we will add a method that will constrain our camera to certain boundaries.